Team Ruby put huge efforts on making Ruby faster, but sometimes we need more speed to make our application faster. So today I'll talk about how to make Ruby application running faster by writing the critical part of application in C using FFI. So I'm John Lin, and I'm the head of algorithm at Spoon Rocket. So what's Spoon Rocket? We are the food button on your phone, and we deliver foods to you in 15 minutes, usually. And in other words, we are a food delivery company. So what's the core of a food delivery company? It's moving food from one place to another, right? So, but doing it effectively is very hard. It's harder than the famous traveling salesman problem. It's an incomplete problem. And here is the screenshot of our algorithm system. As you can see, there are cars, and one looks like a Facebook Live. It's actually a hamburger and a drink. And you present an order. So the number above the order is the estimated delivery time of the order. And the order and the car are in the same color if they are assigned to the driver. So we try various algorithms, try to get optimal assignment. And we make some implementation and test with simple data. But after we try to test it with production data, we got error. So we got error timeout. Why? Because our algorithm is not fast enough. But it worked fine on our simple test case. Why it fails on production test? Because the real world is more complex than the simple test case. There are too much driver and orders, make the input size increase dramatically. And because our algorithm is not a linear time or quadratic time, it's more like a exponential time algorithm. So it cannot be finished within the allowed time of Heroku. So we need speed. And we can solve the problem if we can make the application 10 times faster. So what can we do? The first obvious one is change language. So we can switch to Go, Scala, Java, or C++, or any native language that's fast enough. But no, we don't want to change to other language because we love Ruby. Because Ruby increases our productivity and Ruby makes us happy, we want to stay on Ruby. So what's other options? We can write our critical part in C using native extensions. There are two major ways to do this. One is using C extension. Another is using the FFI gene. And about C extension, it's writing the critical part using the Ruby C API. So you write your critical part in C using the Ruby C API to define functions of Ruby and transform the Ruby object into C objects. But you need compiler on the production system. So we usually don't want compiler on production system because it might cause tons of trouble. And it's hard to deploy. So because it needs compiler, it's also not portable between platforms. And the other option is foreign function interface. It's used libFFI, it's a C library, to mount C functions as Ruby methods. Because it uses libFFI, which uses ABI to call the function, it doesn't need a compiler. So it's more easy to be portable between different platforms. And what's the difference between C extension and FFI? If we split our application into two worlds, one is the Ruby world, another is the C world. For C extension, we write our application in Ruby. But we have to define Ruby method in C using the Ruby C API, and also do all the type converting between Ruby and C. And last, we can have to do the computation. But what if we use foreign function interface? We still write our application in Ruby, but we can also import C function as Ruby method using FFI in Ruby. Also, the FFI can convert the type between Ruby and C for us automatically. So the only thing we have to do in C is do the actual computation. And because C is a much lower level language than Ruby, the more we code in C, the more mistakes we might make, like tons of bad assets. So we decided to go for FFI. So because libFFI gem is a wrapper around libFFI, so how does libFFI work in C? So next section will contain some of the C code and some of the computer architecture. So we have to load C library into the memory, then locate the function in memory, and define its signature, and that's code it. So how does the C library looks like in the memory? It contains some headers and a text section, which will store all the functions and procedures, and data section, which will store all the variables. And last, a section header table, which store offset to the function and variables. And how do we load library in C? We use dlopen. It's a system call in Unix. So you pass it the library file path, and you load the shared library for you, and we locate the address. And after we load library, we can find the function address. So you can see on the left side is the hexadecimal representation of memory address of the symbol on the right. So every symbol has its address, including function and variables. So how do we do it in C? Also, there's a system called dlsym, which can find a symbol address for you. And after we get the address, how do we code the function? So there's different coding conventions for different binary interface. So here is the standard one for x86-32. So basically, you just push all your parameters into a stack, and your return address to a stack, and do the function code. But it's too hard to do this in assembly. So how do we do it in C? So we can call function by address in C by casting it to a function pointer. So you can cast the address to function pointer by casting it. But you have to do all the function pointer declaration at compile time, which means it's not very flexible. So we will usually use libFFI to call the functions. So first, you have to define function signature, which means you have to define what the function wants for its arguments and what does it returns. So you pass it to the libFFI function, FFI prep CIF, and the CIF here represents for code interface. And after we define the interface, we can finally invoke the function. So we can use FFI code to call the actual function by its address using the code interface we just defined. And we should also provide the return address of the return value and the list of arguments we want to pass it to the function. So in summary, you can load library with dlopen, locate function with dlsym, and define signature with prep CIF, and call the function with code. But it's too hard to do it in C. So there's a wrapper for Ruby called RubyFFI. And its concept first appeared in Rubinius. And currently it's maintained by the JRuby team. And it's available in MRI, JRuby, and Rubinius. So you use gin install FFI to install it. And next, here's a Hello FFI example. So to use FFI, first you have to require FFI and define a module for the function you want to attach. Then you extend FFI library to get all the class methods for defining the library. Then use FFI lib to load the library. And last, you can attach the function by symbol name. followed by an array of types of input parameter. And the last one is the output type. And you can call the function, the C function, use just simple Ruby syntax. And you'll do the type converting for you automatically. And about loading library, you can load multiple libraries into the same module. So you don't have to create multiple modules for libraries. And also, on different platforms and systems, there might be different names for library. So you can also provide an array of alternative names for the library. And if you don't like the function name in C, you can rename the function for Ruby. For example, you can rename printf to cprint. And also, FFI also supports variable length arguments. So you can pass more than one argument, and it's not a constant number to FFI. So the type supported by FFI are integers with various lengths, floating points, string, and pointer. And for pointer, FFI can handle the allocation and free for you. And they also support writing various data into it. And what if we have more complex data than simple types? You can also define C structs using FFI. So here we define the time val struct. So you got the two fields, one is second, another one is microsecond. We can define it using FFI. So for using the struct, you just pass it as a pointer, or you can pass it as type. So for here, we want to extract the result using pointer. So we pass the time val object we just created into the C function, which accepts the pointer of the time val struct. And after we call the C function, you output the time val for us. And sometimes C function needs function pointer to act as callbacks. So here we take qsort for example. So it takes the memory address as base and number of elements and the size of each element. And the last argument is a function pointer, which accepts two arguments. And it should return the bigger one. It should return positive if it's larger. And how do we define callbacks? So we use the callback method, and we give it a name called qsort comparator, and takes two pointer as argument and return an int. So we use the callback as usual types in the attach function. And last, we can use the callback by using it as a simple block. So we can get rid of using a separate method to define the callbacks. So to summarize, what features does FFI have? You can load library, invoke function, convert object, and define struct and use block. So at last, the main problem is how much better does it perform compared to ordinary Ruby? So here is a benchmark which find eigenvalue and eigenvector of a matrix. So we benchmark runtime of Ruby, simple Ruby built-in matrix class in standard library, and C extension using LAPACK. I know it's an unfair comparison because LAPACK is a lot more faster and it's optimized, but the point of using native is we want to become faster. So the performance is that FFI is roughly 15 times faster than Ruby. But C extension is twice faster as FFI. And I think it's because FFI has too much type conversion automatically. And the takeaways are, don't give up Ruby too quick if you need speed. And how does FFI work under the hood? And the core feature of FFI. Thank you for listening. Any questions?
有没有人有任何的问题呢 ？Any questions?
Hi. Talking about the FFI, there are two gens can use it. One is FIDO, the other is FFI gen. What's the difference and which one you recommend to use? Thank you.
For FIDO, it's built in Ruby MRI since 1.9.3, and it's supported by JRuby. It's also supported by JRuby, but for recommendations, I would suggest use libFFI because it's older and I think it's more stable, and it has more functionality, such as converting, like handling pointers.
Is there any benchmark difference?
Sorry, I didn't test it.
Okay, thank you.
Any more questions? 还有人有任何问题吗 ？OK， 好，那我们谢谢我们的讲者。